Hello folks, welcome to Marshable Math. My name is Mr. Marsh. Today's lesson is going to be on graphing quadratics that are in vertex form. So get yourself a piece of paper and a pencil and let's jump right in. Okay, vertex form is called vertex form because it gives us perhaps the most important thing about a parabola, and that is the vertex. Vertex is either going to be the maximum or the minimum, and it has to be written in this form where you say that y is equal to a times the quantity x minus h squared plus k. The x's and the y's are the ordered pairs on the graph, and then these a's and h's and k's are some different values. So the first thing we have to do if we have one that's not in vertex form is actually to put it in vertex form. So we do that by completing the square. So coming over here to the problem that I've got, let me complete this square here. Let's see, I first need to group these two together. Now I need to rewrite x squared minus 2x, leave some space here, minus 3. I'm going to need to take half of the b term and square it and then add that back in. So half of 2 is 1, square that is 1, so I'm going to add in a 1, but I can't change the value, so I have to undo it outside the parentheses by subtracting 1. This is now a perfect square trinomial, so y is equal to the quantity x minus 1 squared minus 4. So this right here is now my equation of the quadratic in vertex form. So let me rewrite that over here. Y is equal then to x minus 1 squared minus 4. The a in this case here is a positive 1, even though it's not written. Okay, so what does this tell us? Well, the vertex is of the form of hk. It's just really a special x and y. So what we need to do is look in the equation here and see what is my h and what is my k. H, as you might be able to see there, h is actually equal to positive 1, and k would be equal to negative 4. Be mindful here, it's okay to just grab the number here that's the k and take the sign that goes with it, but when you're inside the parentheses, remember it's x minus h, which means you have to take kind of the negative of what you see right there. So the h in this case is positive 1. If it had been something like x plus 2, your h would have been negative 2. Okay, so the vertex is 1, negative 4. So now what I need to do is I need to think about which way the parabola opens. Well, the a value determines that. If the a is positive, it opens upwards, and if the a is negative, then it opens downwards. In our case right here, the a is positive, so that I know that it opens upwards. So let me plot my vertex, and then we'll discuss what this means here. 1, negative 4 is going to be this location right here. 1, down 1, 2, 3, 4. Okay? So from this location, I know that it's going to open upwards. Now what I need to do is I need to find out my y and my x intercepts. If it opens upwards like this, it's bound to cross the y-axis and it's bound to cross the x-axis here. Okay? So it opens up because a is a positive number. My y-intercept, where is it going to cross this graph or this line right here? It crosses here when the x value is 0. So analytically, what I can do now is say, all right, I'm going to set x is equal to 0, and I'm going to solve it for my y value. So coming back up here, I'm going to go ahead and use this form. We could use either one at this point. I'm going to use this one here since we're going to do it from vertex form. So vertex form, y is equal to x minus 1 squared minus 4. I want to set x is equal to 0 and find out what y is. Y is equal to 0 minus 1 squared minus 4. Okay, so minus 1 squared is positive 1 minus 4. I get y is equal to negative 3. Now, you got to remember, though, the intercepts are points. So this is actually the point when y is negative 3. And what was the x? The x is 0. So the y-intercept then is going to be 0, negative 3. So as this opens up, it's going to cross that location right there, right? X of 0, y of negative 3. Interesting thing about parabolas, they're nice and neat and orderly. There's actually a symmetry to them. So if this is my bottommost point, what I've actually got here is I've got a little imaginary line that we usually don't graph, but I'll show it here just so you can see it. This is called the axis of symmetry. So whatever shape it takes on the left will be the shape that it takes on the right side. So if I have a point here that is 1 unit away from the axis of symmetry, I've got to have a duplicate point right there. I don't even need to figure it out. I just know that this point right here, which is, what is that, 2, -3, will actually be on the graph. Speaking of which, what is the graph? What is the graph of an equation? The graph of an equation is the collection of all the solution points. So actually, if you plug in 2, -3 for your x and for your y into our equation here, bet you $1 that it'll solve it. All right, so moving on now, x-intercepts. If the vertex is down here in the bottom and it opens up, I know that it's going to cross the x-axis at some point. Now, if it had been the vertex here and it would have opened down, I could have told right away that it wouldn't have crossed the x-axis, and so I wouldn't bother looking for an x-intercept. But I know this one does. So if the y-intercept is when x is equal to 0, what is the x-intercept? Well, that's when y is equal to 0. So let me take my equation here again, and let me set y is equal to 0 and solve it. So the y value then is 0. That's equal to x minus 1 squared minus 4. I'm going to solve this one here by extracting the root. So what we're going to do is add 4 to both sides. So 4 is equal to x minus 1 squared. Now I've isolated my squared term. How do I undo a square? Square root it. So square root the left and square root the right. This right side becomes x minus 1. What's the square root of 4? Y'all should know that is 2. But be careful, because this question says what when I square it gives me 4. I've got a positive and a negative 2 there, okay? Don't forget that. Now, continue to solve for x. I'm going to add 1 to both sides, plus 1. So in the end, what I get is x is equal to 1 plus or minus 2. I actually get 2 solutions, right? So this is going to be x is equal to 1 plus 2, which is 3, and also 1 minus 2, which is equal to negative 1. But remember, these are points. And didn't I expect to get 2 points here where the parabola crosses the x-axis? So x is equal to 3, 1, 2, 3. That's this location here. And x is also equal to negative 1. That will be this location here. I see the parabola starting to take shape. I really should get 7 points altogether. I should get 3 on the right side and 3 on the left side. So let me do one more point. Let me take either something on the left or something on the right. Let me take the right side value. This is x is 1, 2, 3, 4. Let me do another point with x is equal to 4 and find out what the y value is. So when x is equal to 4, that would be y then is equal to 4 minus 1 squared minus 4. 4 minus 1 is 3 squared, 9 minus 4. I get y is equal to 5. Okay, so I combine these now and I have the point 4, 5, which then is a solution, right? Because the graph of an equation is the collection of all the solution points. So now it's going to be 4, 1, 2, 3, 4. 1, 2, 3, 4, 5. So up here. But if I'm 3 units away, remember the axis of symmetry, 3 units away, I've got a location right there too. Okay, so now that I've got some points in here, let me fill in the rest of it. It's the collection of all the points, but when we put them all together, it forms a line or a solid kind of a curve. We got to remember that the parabola is not a knife point. It needs to be a smooth curve. So starting down here, I'm going to draw, hopefully as smooth as I can, up through these solution points here, and then mirror image on the other side. It's difficult to do on the whiteboard. And if you mess it up, don't be afraid to take a eraser and start over again. Set. A little bulgy right there. And let's say smooth, nice curve down in here. Okay? Goes on forever. Alrighty? So, from vertex form, we want to find the vertex. We want to find out whether it opens up or down. We use that with the a term here. We want to find the x and y intercepts. We do that by setting each one of those equal to 0. For the y-intercept, we set x equal to 0. Solve for y. That's its own point. For the x-intercepts, we set y is equal to 0. Solve for x. Those are its own points. Usually you're going to get 2. Sometimes you might get 1. Sometimes you might get none if it's above and opens up or it's below and opens down. And then maybe fill in a couple other solution points to find out where it goes. Okay? Hope you're having a great day.